Thanks, Brian. So I just want to also give shout out to the whole LocalStack team, and especially to Snowflake team, to Erudit, Sabir, and Gentries for the tremendous amount of work we've put into making this happen. And special shout outs also to Valdemar for support along the way. We really appreciate that. So yeah, I would like to dive deeper into what's new in LocalStack for Snowflake in V1 release. So yeah, let's kick things off. So we added support for native apps, and so Snowflake Emulator now supports it, enabling you to build, test, and validate native applications locally. So basically, you can create your application package, then create application from that application package, and even you can embed a Streamlit application inside a Snowflake native app. And Streamlit is Snowflake framework for building apps. And if you want to give it a try, you can go to native apps example repository which Snowflake published, and you can choose one of the examples and just give it a try with the emulator. It will also demo one of the native app later on, and this demo will be presented by Erdit. Yeah. The next feature we added is Polaris catalog integration support. So Polaris catalog is an open source catalog implementation for Apache Iceberg. It follows the Iceberg REST catalog specification, and it enables multi-engine interoperability. Polaris supports different query engines and database platforms like Snowflake Dremio, also Trina, which I also going to present later on. And in order to use catalog integration with Snowflake Emulator, we need to run create catalog integration query, which is presented on the left-hand side. But I will dive into more details during my Polaris catalog integration demo later on. Next feature is materialized views, and LocalStack Snowflake now supports materialized views, allowing developers to create pre-computed persistent views. Standard materialized views support into database space, and we support the following operations like create, alter, describe, drop, show, and truncate. Next feature is row access policies, and it allows developers to implement test fine-grained role access controls locally. So basically, you can create a table first with this query on the left-hand side, then create a row access policy that is basically masking a column username here, and then enable the row access policy on the table using alter table query here, and we're just basically adding the row access policy to a table and enabling it on the username column. Recently, we added also multi-account support. So as you are aware, Snowflake supports multi-account configurations, allowing to having multiple accounts in the same instance. And we do support it right now, and we do this by provisioning separate Postgres SQL backends for each account to ensure that we have complete separation and isolation of data and namespace. And this is very useful for testing multi-tenant applications or workflows across different environments, different stages and accounts. Next feature is transaction management. So previously, we supported only auto commit mode. So all operations were automatically committed to underlying database. And right now we are enabling developers to have like more explicit control over your transactions using standard SQL commands like begin to begin that transaction, then commit to commit the transaction, rollback to rollback the transaction, also select current transaction function to show the current transactions, and show transaction to show all open transactions being open. Another feature is passwordless authentication. So Snowflake emulator supports right now passwordless authentication, and it's basically you need to generate an RSP keys, and then attach the public key to your username, and then use the private key in your Snowflake connector configuration. For example, like in here we are using Snowflake Python connector, and we are pointing to RS key, private key, via the private key file property here. So it's very useful, and I think right now Snowflake enforced MFA for every account. So yeah, that might be your default authentication option right now. So we also emulate that functionality. Another feature is Java UDFs. So we added support for Java UDFs. We had support for Python UDFs and JavaScript UDFs, and we added also support for Java UDFs. So what we can do now is we can create a function and then point to a Java language, choose a version of Java, and then point to a stage in Snowflake where your built and compiled jar is located. And then the endpoint to the handler, which is the function, the method in the Java. And after it's created, you can basically use this concat string function in the emulator. So that's a pretty cool feature. So yeah, we are kicking off tech demos. That's a pretty exciting part. So I'm gonna present Polaris catalog integration, and then Erudit will present 2 more demos afterwards. So before I start, you can find my demo by using, you can use this link or use the QR code to follow along, and maybe like try it out, and maybe also like share some more feedback on how it works, and just give it a try. So before I start, I would like to present like a diagram what's going on in this demo. So we have 4 different components. One is LocalStack Snowflake emulator. Second one is Polaris catalog. Then we have LocalStack S3 object storage bucket, which would contain Apache Iceberg tables with all metadata files and Parquet data files, and also Trino, which is distributed query engine as an external query engine, just to show the interoperability in Polaris catalog. So everything will be spin up using the Docker Compose locally in 3 different images. So Polaris catalog is as a 1 image, LocalStack Snowflake emulator and LocalStack S3 as the 2nd image, and Trino as 3rd image. And LocalStack Snowflake emulator would talk to Polaris catalog via catalog API. Same for Trino, and LocalStack and Trino will talk to LocalStack S3 local object storage bucket to read and write data. And Polaris catalog will exchange the metadata, and we handle the metadata management between bucket and the catalog. So yeah, I think that's all slides. So let's kick off the demo. So first of all, I can quickly show Docker Compose here. So as I said, this is LocalStack Snowflake that contains Snowflake emulator and also S3. Second image is a Polaris catalog image, which is maybe I will just make it a bit bigger. Okay, so Polaris is the second image with some extra configuration, which points to endpoint, which points to LocalStack endpoint, and is using like some LocalStack specific configuration to AWS. We are also running like a short bash script to set up a catalog within Polaris catalog that will be used by LocalStack Snowflake. And the last image is Trino, which has Iceberg connector configured that points to Polaris catalog and also to LocalStack S3 bucket. So yes, let's run it. Docker compose up. It'll take a while to initialize. I'll move it here a bit. Okay, so this is still starting. So yeah, first thing we need to do, we need to create a bucket here. So I'm going to use AWS local CLI wrapper around AWS CLI to create test buckets. And let's wait a second. So bucket is created, and we can proceed with a demo. So on the left-hand side, I have a dbeaver running, which is connected to LocalStack Snowflake emulator. And first of all, I need to create an external volume, which points to bucket that I've created, test bucket, and just like some extra configuration to the external volume. So yeah, creating external volume, it succeeded, so we can proceed further. The next step is to create a catalog integration. So here we are pointing, we're calling our catalog integration Iceberg catalog. Then catalog source Iceberg REST, table format Iceberg. We're calling catalog namespace test namespace, and we are pointing to locally running Polaris catalog. And some extra authentication credentials to Polaris catalog. So let's create catalog integration. It's successfully created. So now we can create an Iceberg table. And here we are calling our Iceberg table. We're pointing to a catalog integration, Iceberg catalog, and to external volume, Iceberg volume. And we are setting some base locations. So let's create an Iceberg table here. The table is created. So then we can insert some data into it. We can see like a lot of movement in the logs on the right-hand side, by the way. So yeah, data is being inserted. Yeah, it's there. So let's select data to see if it's there. Yes, I can see the data is there. So let's see right now what is in the bucket. After we created the bucket, then we like created a table, populated the table, and we can see that there's anything else there. So let's do list objects from test bucket. And here we are. Here we see some Parquet files Parquet data files associated with Iceberg tables, and metadata JSON file, which is Iceberg metadata files. So we are seeing that Snowflake emulator actually wrote the tables, the metadata and the data files here. So let's right now, as a last step, test the interoperability, whether we can actually query this data from a different engine. So what I will do is run Trino CLI. So I'm using Trino right now. And I'm switching context to use Iceberg catalog and test namespace schema. And I can just run a select from Iceberg table. And yeah, we see the data, and we can successfully query Iceberg table that was created from LocalStack Snowflake from Trino. So we presented the interoperability of the whole setup and demo.